I want to say thank you for watching the last video. Stayed connected and watched to the end. Now, how many factors? I think we treated the first part, finding total number of factors that a number have, right? Using the 4 steps I explained. Please, if you are watching for the first time, I will advise you go watch it, as I'll be doing a brief intro on that. So, today we are going specifically to look at how you can extract odd factors of a number and how you can extract even factors of a number. It is actually very simple. So before you start treating number 1 and 2, you have to find all the factors of a number. So let's go into that. Okay, so the first step is find all the prime factors of that number. That is prime factorization. I will advise you go and watch the first video and then you understand how I got this table. But for the sake of those, I would like them to stay connected. Let me explain briefly. So when you're given a number, think of two numbers that if you multiply, it will give you that same number. They must not be prime numbers, just two numbers. So this and this will give us this back. But since they're not prime numbers, I'm still breaking them down. Look for other two numbers that will produce this. So 3 times this will give you that. But see, 3 is a prime number. So once you notice a prime number, circle it. 72 is not a prime number, but I know that 8 times 9 will give me 72, but 8 and 9, they are not prime numbers, right? So in case you don't know what prime numbers are, I'll be dropping a video so that you know what prime numbers are and how to use them. So 8 can be written as 2 times 4. 2 is a prime number, 4 is not. So 2 times 2 will give you 4, and since 2 and these 2 are primes, those are the prime numbers on that branch. 9 can be written as 3 times 3, and 3 is also a prime number. Now let's go to the other branch. Remember, it was this one and this. We are done with this. 4 times 25 will give you 100. 4 is not a prime number, 25 is not a prime number. But 2 times 2, they are primes, and 5 times 5, they are primes. So the first thing you do is write out the prime factorization. So we have 2. How many 2's are in this diagram? We have 1, 2, 3, 4, 5. So instead of writing 2 times 2 times 2 times 2 in 5 places, just write it as a power. Then multiply. The next number we have is 3. How many 3 do we have? I have 1, I have 2, I have 3. So we write it as a power. Then we have 5, and then we have 2 5. So step 2 says list out the exponents. List out the exponents. So our first list is going to be, when we talk about the exponents, they are the powers, right? So let me use this time I explain. If I now write 7, for instance, without an exponent, know that it is raised to the power of 1. So in case you come across something like that, you take note. So for this case, the exponent of 2 is 5, the exponent of 3 is 3, and the exponent of 5 is 2. So the third step says add 1 to each exponent. Add 1 to each exponent. So this will give us our new list. So the new list is now going to be 5 plus 1. It will give us 6. 1 plus 3 will give us 4. 1 plus 2 will give us 3. And the final step says multiply the new list. So these are the 4 steps you take in finding multiples or all the factors of a number. So this is 6 times 4 times 3, and 6 times 4 times 3. Let's go with the smaller numbers. 12 times this will now give us 72. So if, for instance, okay, that's the first question. How many factors does 21,600 have? So it means the number in total have factors of in total of 72, including 1 and 21,600 itself. Remember, for short numbers or for smaller numbers, we can use the pair method. If I have 6 and you ask me to find the factors of 6, I don't need this. All I need to do is 1 times 6 will give me 6, 2 times 3 will give me 6, 1, 2, 3, 4. It means 4 has total number of 4 factors. So let me show you how this method will also work for 6. So let's see here. 2 times 3 will give me 6, right? Now, this is 2 to the power of 1. This is 3 to the power of 1. This is the first step. The second step says list out all the exponents and then add 1 to it, right? And then multiply. So you can see that using this method gives us the same thing. So you can as well use it, but for smaller numbers you can use the listing method. Now let's go back to the question on ground. So question 1 says, out of the 72 factors that this number is having, how many are odd factors? So I want you to know that to find odd factors, it is almost the same way as finding all the factors. So here are the 3 steps you have to consider. This, I call them the 3 steps because already you have created the prime factorization list, right? So now let's take a look. So here are the 3 steps. Have you noticed any difference? Yes, the difference is only in this. So to find odd factors, go to your prime factorization list, write out exponents of all the odd numbers only. So let's come to here. Sorry, this is kind of crowded because of the other example I showed. So come here. That is our prime factors, right? So 2 is not an odd number, therefore I'm not going to write 5. 3 is an odd number, so I'm going to pick the exponent of 3. 5 is an odd number, and I'm going to pick the exponent. Remember, odd numbers cannot be divided by 2 without a remainder, right? So 2 is an even number. 3 cannot be divided by 2 without a remainder, and all of that. So the list is going to be just 3 and 2. Remember, when we're looking for all the factors, we carried every exponent regardless of even or odd. But when you are looking for odd factors, carry the exponents of only the even, or only the odd, sorry for that. So this is what we have. Then add 1 to each. So after this, every other thing remains the same. So this is going to be 4. 4 plus 1 plus 2 will give us 3. Then multiply, and this will give us 12. So it means out of the 72 factors, only 12 are odd factors. So how then can we find all the even factors? Are you expecting to get a guideline as the rules again? No. Now I want you to know there is no straightforward formula or steps in finding even factors. So all you have to do is, if A plus B gives me C, and take it that this is odd, this is even, this is total, and I have my odd, I have my total, and I'm looking for even, I have to subtract. So even can easily be gotten as total minus odd, and this is because there is no straightforward, because see, look here, if I say pick only the exponent of even and multiply, there's nothing of such, and it will give us a wrong answer. So the even factors here, the difference between total and odd. And remember, our total, we have 72, our odd, we have 12. So 72 minus 12 will give us 60. So in total, we have 72 factors for 21,600, 12 are odd, and 60 are even. Thank you, Mr. Josh, for the question you sent. It actually shows that you are enjoying the classes. So if you have any problem, you can share, and then I will try as much as possible to explain. So try this and try your own examples. Thank you.